Alrighty, let's go ahead and tackle the end of lesson 2-8, Unit 2, Section 8, inverse functions, finishing it up today. Yesterday we talked about inverse functions and what they mean. We said that a function has inputs x, outputs y. Its inverse will switch the x and the y. So y's go in, x's come back out. Just like inverse operations, inverse functions will cancel regular functions, whatever they're the inverse of, in either order. And if a function is 1-to-1, that implies that it is a function and so is its inverse. That was basically what we talked about yesterday. Cool. So let C of m be the cost of Wow, that was fast. Someone's already at the door. Getting interrupted like that. Let C of m be the cost in dollars of m ounces of mangoes. What do the following statements tell you? And make sure that you use units. Okay. Input is ounces of mangoes. Output is cost. So then what this tells us is the cost of 12 ounces of mangoes is 75 cents. There you go. That's what that tells us. Just to save a little bit of time, and so we're not doing redundant things, I'm not going to write this one. We'll just say what it is. And you'll do the same. You won't write it down because, again, I want to move on. But it says the cost of 8 ounces of mangoes is 50 cents. Now, in examples C and D, we're not using function C. We're not using the cost of m ounces of mangoes. Instead, we're using C inverse. That means input and output have switched. So when we were talking about C of, our output was money. Since these say C inverse of, their input is money. Again, input was weight, output was money. Input is money, output is weight. Sage? Okay. So now the input is money, the output is the weight. So let's see, how do we want to word this?
$3 worth of mangoes is 48 ounces.
Ooh, that's good. $3 worth of mangoes weighs 48 ounces. Good. Boom. And likewise, this will say 75 cents worth of mangoes weighs 12 ounces, which of course we already know from what we have there in orange. Cool. Everybody comfortable with those? How inputs and outputs are switching? And okay with describing it in words?
Yes.
Awesome, because here we have a frustratingly large amount of words. Suppose W equals P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. Again, water needs of a palm that is this tall. So X is the input, that's the height of the tree. So if you know the height of a tree, you can determine the amount of water it uses in gallons. So it says, what does the expression P of 25 represent? Well, P of 25 would be equal to some W, would it not? So we get W equals P of 25. The input of function P is height of a tree. So this describes the water needs of a palm tree that is 25 feet tall. It's actually the average daily quantity of water. But we're just saying the water needs of a tree That is 25 feet tall. Just like the mangoes example, the moment we move over to the inverse, our input and output have switched. The input for function P was height. The output was water amount. So for P inverse, its input is now a water amount. So this is x equals P inverse of 25.
It's x equals, or
Yes, because here it was W equals and the input was an x. So the moment you move over to an inverse, x is no longer an input, it is now an output.
oh, so you want
So
W is 25.
there you go. So that tells you W is 25. So this says the height of a tree that needs 25 gallons of water. Because once again, height and water have changed places. This is back to function P. Function P's inputs are height. So if you say P of V equals 50, what does this tell you about V? Anyone want to take a stab at that one? Not looking for a numeric answer. I'm looking for an explanation of what it says. Okay, want to give it a shot? All right, Max, what do you got? You're thinking. You guys need me to do it?
What is V?
Oh, wait, well, that's what the question's asking. What is V? London, take a shot at it. We're not looking for a numeric answer. We're looking for an explanation of what this says. Is what the height? What amount of water? So we're trying to explain in words what this tells us. No. We're not looking for an. Okay, so this is 50 gallons of water. What does that tell us about V? This is the height of a tree. So here's what this says. A tree of height V, feet, uses 50 gallons of water per day. There you go. A tree of height V feet uses 50 gallons of water. It says to rewrite that equation in terms of P inverse. Okay. 50 gallons of water equals a V foot tree, but what would that look like using P inverse? There we go. He says P inverse of 50 equals V. Yeah, so how do we get there? We start with our equation. P of V equals 50. Leave a little bit of space. P inverse can be thought of as being an operation that cancels P. So you can do P inverse of both sides of this equation like this. On the left side, P and P inverse will cancel each other out and will leave behind just a V like Gavin said. There it is. So anytime you need to use an inverse function, it's something that is done to the entire side of an equation, just like an operation would be done to the side of an equation. We're now told that palm trees are, on average, Z feet tall. And a tree that is that average height is going to use K gallons of water. We're going to represent that fact in terms of P and in terms of P inverse. Straightforward, P of Z, a palm tree of height Z uses K gallons of water. And if you want this fact in terms of P inverse, then the input and the output change places, and you say P inverse of K equals Z. So in words, a tree that is Z feet tall uses K gallons of water. A tree that uses K gallons of water is Z feet tall. Comfortable saying it backwards and forwards? You guys cool with that idea? Good, because as far as I'm concerned, now comes the hardest part of the lesson. Taking those two facts and interpreting what all of these transformations mean in terms of the real world. So at the top of the paper, so I don't have to flip it back and forth, I'm going to write down the fact that we just had. A tree of Z feet tall uses K gallons of water, and a tree that uses K gallons of water is Z feet tall. So if you write 2Z, what have you doubled? We've doubled Z. Z is the height of the tree. So what this describes is the water needs of a tree that is twice the average height. So then, if this is doubling the height of the tree, yes, Max? Oh, then what is that one doing?
2 trees.
So, 2 trees. I wonder if it would work that way. I mean, you could think of it that way if you wanted to think of it as 2 trees, but that's what it is. It's twice the amount of water. Yeah, which technically, if you had 2 trees, you would use twice the amount of water, right? But I think what we're going for here is twice the amount of water that a tree of average height requires. These 8 questions are the hardest thing for me in the whole lesson. Just thinking about what does that do? What does that mean? So again, the input here is height of a tree. The output is the water needs. There you go. The water, yeah, good. The water needed for a tree that is 10 feet taller than average. All right, so we're kind of getting it. I don't want to go through all 8 of them just because I want to make sure that I finish the lesson in time today. And we still have to finish this page and the back. So let's pop through, do a couple of these inverse ones and call it a day on those. How about this one? So the inverse thing. This says water, K is the water needed, right? So this is the height of a tree when, why am I struggling with my words today? This is the water needs of a tree of average height. This is the height of a tree that uses this much water. There we go. So what is this one telling us? Oh, Max, you weren't raising a hand? Oh, okay. Sorry, I thought you were raising a hand. So we know that K is a water amount. And the output is height. So this is going to be, yeah, want to give it a shot?
So since it's inverse is K height now?
Well, no, so K is always going to be a water amount. So K, so see, and here it's still a water amount. So here, this is what this says. A tree of average height uses K gallons of water. And this says
A tree, or no,
you uses
K much water.
So would you say
A tree that uses that much water
is that tall? There you go. So a tree that uses this much water is this tall.
Okay, so it stays the, okay.
So then this one says a tree that uses, yes? What were you going to say?
I was going to try and say
Yeah, go for it.
the height of a tree that uses 10 more gallons.
There we go. So this is going to be the height of a tree that uses 10 gallons more than average. Let's get one more of those going. These two are basically the same kind of question, so we only need to do one of them. I say we do that one.
The height of a tree that takes 10 more, that, no.
Ah, see, that was that one, wasn't it?
The height of a tree.
How about this?
No, how many gallons it takes
So,
for a tree to be more than 10 heights.
what is he? This man just had a word salad. Okay, P inverse of K is right here. This is a tree that uses this much water is this tall. So this says a tree that uses this much water is
10 more than average height.
There we go. This is affecting the height. This is affecting the height. Because if you add 10 to this side, you add 10 to this side. So this says a tree that uses, hold on, now I'm going to butcher it. I told you, this is the hardest part for me. I'm going to screw my words up. Walter, fix those words for me, please. See how hard that is?
I know what it is. It's just
Yeah.
like articulate. Is it a tree that is 10 feet higher than a tree that uses a normal amount?
Of water, yeah. So this is the height of a tree is 10 feet taller than a tree that uses a normal amount of water. Do we want to say it like that? Is that good English? What's that? 10 more than average. So say the whole sentence for me so I write it good. This much water. Yeah, this is the water used by a tree that is 10 feet taller than average. There we go. I think that's the best way. Is that how you want to say it? It still feels wrong, though.
Putting a tree that uses the same amount of water is 10 feet higher than...
It's so weird. The water needed for a tree that is 10 feet taller than average. I like that. The water needed... Yeah, it's tough to say it in words. Math is so much better with symbols. The water needed for a tree that is 10 feet taller than average. Okay, we're going to stop doing these, though, before I start looking stupid. And we're going to move on to just symbols, okay? Because just symbols is easy. Words be hard. Symbols are easy. When I teach inverses to my IB students and to my Algebra 2 honor students, I try to drive home a really important fact, and that is that When you're talking inverses, you have literally switched inputs and outputs. So I try to stop saying X's and Y's because they get a little confused. But if you say inputs and outputs, I feel like it makes it easier. If -4 is an input on the inverse, then -4 must be an output for F. Let's go ahead and write that in words. -4 is an input of F inverse, so -4 is an output of F. So if you would like to evaluate F inverse of -4, you think to yourself, well, if -4 is an input on F inverse, -4 must be the output of F. Go to F, find output of -4, and see the X that is associated with it, and there's your answer. Was that okay or no?
Yeah.
Okay. And the same logic can be used when you're talking G and G inverse. If 6 is an input of G inverse, then 6 is an output of G. So you go to G, you find output 6, and you look at the number associated with it. Input and output have switched places. Okay, Sage, one more time. Ready?
I'm still looking at the first one, and I'm just so lost as to how...
If it's in parentheses, you're comfortable calling it an input?
Okay, sure.
An input of the inverse is an output of the original, because inputs and outputs have switched places.
Okay.
So if -4 is an input of F inverse, then -4 must be the output of F. So you go to F, you find the outputs, you track down -4, and you give the number associated with it.
Wait, how do you know that the left table was outputs?
No. This, you mean this column was outputs or this table?
How do you know that that column is outputs?
Because outputs are typically Y values.
Oh.
So here's X is inputs, F of X is outputs.
Oh, okay, I get it.
Okay?
I think we're asking a question.
No, you're good.
No, Max was getting pressed.
Well, Max can be pressed all he wants. Okay, G of 1. Peel this onion. Go from the inside out, though. We're going to start on the inside. G of 1. What does G of 1 equal? G of 1 equals -3. So this question actually says, what is F inverse of -3? Well, let's find out. If -3 is an input of F inverse, then -3 needs to be an output of F. And yes, it is 3. Good job, Max. You just guessed. Okay. I'm less impressed now. Less impressed. Alrighty. See if you guys can tackle G inverse of F of 0 without me real quick. Go for it. I'll pause the video so we don't have to have a gap of silence. Okay, so for sake of finishing on time, I say it all at once. On the count of 3, you all shout out your answer. This ought to be fun. 1, 2, 3. 4. See how I did that? I did that on purpose. So I would say 1, 2, 3, and you guys would all shout 4. Got him. It's 4. But why is it 4? Here's why it's 4. First, F of 0. So go to 0, figure out what F equals. Boink. It's -1. So this actually says G inverse of -1. If -1 is an input for G, then -1 is an, if -1 is an input for G inverse, then -1 is an output for G. -1 output for G is associated with the number 4. There it is. And we flip it over to the back. Okay, the algebra intensive question. The algebra intensive question. Here we go. This function is 1-to-1. That means its inverse is also a function. I'm going to call it F inverse when I find it. So I have to switch X and Y, and I have to isolate Y, and when I do, it'll be called F inverse. Your very first job is to switch X and Y. we are trying to isolate y. The problem here is that y is going to be in the denominator and the numerator. Oh my gosh, fractions, right? You know what I mean? So because y lives in the numerator and the denominator, but I'm trying to solve for y, I need to get rid of the fraction. I'm going to multiply both sides by the denominator. On the left side, whee, they're gone. On the right side, I know my left from my right. Who said I don't? The y plus 2's are gone on the right side. On the left side, you're going to need to distribute this x. That's going to give you xy plus 2x. And on the right side, all that's left is 2y plus 3. Once again, we're trying to isolate y. We have y's on both sides of the equal sign. What we need to do is gather all of our like terms, all of our y's on one side. And if something doesn't have a y, send it to the opposite side. I'm going to bring all my y's left. And I'll send all my non-y's to the right. I ran out of vertical space. I now have xy minus 2y equals, and it's not wrong to say 3 minus 2x, but it's weird. I'm going to say negative 2x plus 3. We're almost there. We're trying to isolate y. Unfortunately, these are not like terms, so I can't combine them. But you know what I could do? I could recognize that y is a GCF, and I could factor it out. If you divide the whole left side by x, what it's going to give you is y minus 2y over x. So you still have a fraction on your hands. But if you factor it out, then you can divide and isolate y. At this point, you would divide both sides by the x minus 2. The y will be alone, and because f of x was 1 to 1, when I've isolated this y, I can call this f inverse of x now. Y is what? Because they're 1 to 1, I can guarantee that the inverse is a function. So I can call it that.
But why is it the inverse?
Y is what? What? Because I found the inverse because I switched x and y and then isolated y. Because that's how we find inverses. We switch x and y and then isolate y. What's that? Well, you would need to be told that it was 1 to 1 to call it f inverse. Because this symbolage implies you're dealing with a function. And 1 to 1 means they're both functions. Now, we've been asked to find the domain and range of the original function. Isn't it strange that it didn't ask us to find the domain and range of the inverse? Well, because they're the same. They're just switched, right? All right. So let's talk about the domain of f of x. The domain of f of x is going to be every x you're allowed to use. This is a rational function. Gavin, you were saying you can't do what with rational functions? You can't divide by 0. So the only x that causes a problem is what? X equals negative 2. You know what happens at x equals negative 2 for f of x? It's a vertical asymptote. At x equals negative 2. That means the domain of f is everything except for negative 2. The range of f, well, this is a rational function that is linear over linear. And what I see is the degree on the top is equal to the degree on the bottom. That tells us that this graph is going to have What kind of structure? Thinking back to our rational stuff. When we have same degree on the top and bottom, we have a horizontal asymptote at what? At y equals 2 over 1. Oh, by the way, look at the inverse and tell me one number you're not allowed to plug into the inverse. 2. Since 2 is not allowed to be used for the inverse's inputs, 2 is not allowed to be used for the original's outputs. See it? Which means the the range of f of x is everything except for the number 2. And just for funsies, if you come down here, check out what it has. It has a vertical asymptote at x equals 2, because you can't divide by 0. And it has a horizontal asymptote at y equals negative 2 over 1. The vertical and horizontal asymptotes have switched places. Well, of course they have. X and y have switched. Isn't that neat? Yes, Mr. Rabbit, so friggin' neat. Okay, I'm glad you think so. He says so friggin' sigma. And then he dabbed when he did it too. Man, skibbity. You know what I mean?
I thought you said you don't know what any of that means.
I know that it means nothing.
It actually doesn't mean anything. It's a cultural reference.
It's a cultural reference? Yeah, it's Skibbity Riz Toilets from Ohio, right? Yep. Means all kinds of things. Listen, all that knowledge I just conveyed. All on video. Triggered, right? My aura just slaps. Okay, so... Did she say got? All right, if a function is not one-to-one, then its inverse does not exist. All right, I want to make a statement about that. I won't say that the inverse doesn't exist. I'll just say that the inverse is not a function. Because you can have an inverse relation. It just won't be a function. But what if you want to find the inverses and you want them to be functions? Well, if you're dealing with something that's not one-to-one and you want its inverses to be functions, what you have to do is you have to restrict the domain of f of x so that it is one-to-one. What will end up happening then is that you'll have more than one inverse function, depending on what domain you chose for f of x. We talked about this yesterday when we were talking about quadratics and square roots. First, what we're going to do is we're going to find the inverse of this function. So let's do that algebraically. Okay? Switch x and y. Our job now is to isolate y. Subtract 2 from both sides. Now, you're going to need to divide by -1 on both sides. It's not wrong to say 2 minus x. It's just a little strange. I'm going to say -x plus 2. And now I need to take the square root of both sides to get y by itself, don't I? There's one small problem here. What happens when you cancel a square with a square root? Say it louder for me. Plus or minus. Yes, they cancel each other, but this is going to create a plus or minus. That means there are 2 inverse functions, a positive version and a negative version. This is not one function. You are not allowed to write what I just wrote. That's not allowed. Nope. because this is not a function. If you graph both of these square root graphs, what you get is a sideways quadratic. This is not allowed. So what I've written here is not true. This is not a function. So what went wrong? What went wrong was I ignored that part. The domain of this quadratic was x is greater than 0. The domain of the function is the range of the inverse. So which one, the positive square root graph or the negative square root graph, has a range of y is greater than or equal to 0? Not quite sure, are we? Tell you what, why don't we sketch the graph of this quadratic and then its inverse? Here is our quadratic. First, let me write it in a way that makes it easier to graph, because now we can see the transformations. This thing's vertex is supposed to be at 0, 0. Turn the graph upside down and shift it up 2. Its vertex is here. You can only use numbers starting at 0 and going bigger. So let's plug in x equals 1. Negative 1 squared, so negative 1 plus 2 is 1. Let's plug in x equals 2. Negative 2 squared, that's negative 4 plus 2. And if we try to plug in 3, we get negative 9 plus 2, that's negative 7. Okay, it falls off the graph. So this is our function. Is that 1-to-1? Yes, it is. This blue curve passes the vertical and horizontal line test. Here is the line y equals x. And if you take the 3 purple dots that do exist and you swap their coordinates, we'll have the graph of the inverse. So if you have 0, 2, swap it to 2, 0. That goes here. 1, 1 is still 1, 1. That's convenient. 2, negative 2 is negative 2, positive 2. I have to turn my paper sideways to get a good drawing, but you get this. So is that a square root graph with a positive on the front or a negative on the front? A positive on the, she says positive and negative. She said them both. You can't say them both. You were just guessing. There's only 2 guesses. So you were waiting until I told you you were right. Remember, please, from yesterday, when we talked about these square root graphs, where the heck is it? Where did I do this? Right here. I did it when we were looking at this slide. I said, if the number on front is positive, it points up because the positive y-axis is up. If the number in front of x is positive, it points to the right because the positive x-axis is to the right. This graph points to the left, the orange one. That is why there's a minus sign in front of x. But because it points up to the positive y-axis, I'm only allowed to use the positive function. F inverse of x is the positive square root of negative x plus 2. So this is not ever allowed to be done. Can't do that. But again, the domain of the original function is the range of the inverse. This thing's range is up from 0 because it's positive on the front. Yes, London?
So if you were to plug in the same inverse equation and paste it down in the same way as the... Can I explain this right? Like, would I use the negative answer instead?
Okay, so you want to know how you would use the negative radical? The negative radical would have been the left-hand side of the quadratic.
Okay, it would just point down.
It still points down because it's a U-shaped graph, but the negative radical is the reflection of the left side of the quadratic. And the reason why is because if you said its domain was x is less than or equal to 0, that means the range of the inverse is y is less than or equal to 0. It would have been this quadratic where you're under the x-axis. You say, yeah, but it's obvious that you didn't believe me. Okay, how about this? How about I do it in a dotted line? Here is the left-hand side of my quadratic. here is its inverse. So the solid things are inverses of one another. The dotted things are inverses of one another. But because we were dealing with the right-hand side of the quadratic, we had to use the top half of the sideways quadratic. Because we were using the positive side of the quadratic, we had to use the positive side of the radical.
How do you know if it's positive or not?
Because this says greater than 0.
Like on the graph was.
The right-hand side is always the positive side.
That's all.
Alrighty. Last question. Now this is a remarkably easy question, but only if you understand what it's asking you. So, your typical AP style question. And those of you that were my Algebra 2 honors students will be used to questions like that because they were always the ones that I gave you for extra credit. They were always the ones that were very easy to do if you understood the math. Suppose f of x and g of x are both one-to-one functions. We know that f of 3 is 5. We know that g of 5 is negative 2. Are these two functions inverses of one another, and how do you know? So Gavin, you said no. Graham, you immediately shook your head no. Graham, why do you think it's no? Ooh, perfect. So here's what he said. He said f of 3 is 5, but g of 5 isn't 3. You see, if f is 1-to-1, then the inputs and the outputs have to switch. So we say since f of x is 1-to-1 and f of 3 equals 5. We know f inverse of 5 must be 3. And then Graham said, since g of 5 isn't 3, f and g aren't inverses. Perfect. That says sing. I can spell. Since g of 5 is not equal to 3, f and g are not inverses. Awesome. Appreciate you, nerds.